Could be more than this one. It could be arma 2 2, arma 3 3, arma 4 4, 5 5, and so on. This is conditional mean equation. Now the other one is conditional variance equation. When we are using the word variance, it means the dependent variable is the variance of the error term of first equation, which is sigma square t. Because we know that our standard deviation is time dependent, that is why we are putting t is here. And the next one is gamma naught plus the variance of the arch process depend upon the square lag value of the error term of first equation, which is known as so this is arch model. Mean equation and conditional variance equation. So the word arch means where is square of this t minus 1. This one? No, there is nothing. Because we already estimate our error in this equation. This is the extension of the first equation. That is why there is no error. Which one? This one? This equation? What do you want to ask? Basically, this equation is the extension of this error term, the error term of the first equation. So that is why there is no more error. Error is already estimated in first equation. So this is the arch process. Arch means the first part is autoregressive. The second part is conditional heteroscedastic. Autoregressive conditional heteroscedastic. This is the condition, and we know that there is heteroscedasticity because the second part of the error is moving with the time, and AR means it depends upon its own lag. So it is autoregressive conditional heteroscedastic. So this is the process of arch model. At this stage, if you have any question, please let me know. अगर समझ नहीं आई तो फिर खैर है. Yes. Basically, in this whole process, there is one arch term, which is known as arch term, and this one is the arch term. This is known as arch term. If you are going to interpret the conditional variance equation, in every textbook you will read it, the conditional variance depends upon the arch term. Arch term means the square of the lag value of residual of first equation. Square means basically if there is a little bit confusion between the square and the error square and the variance and the standard deviation. So for the square, just note that basically when we are trying to estimate the variance, what is the formula of variance? We are saying that sum of xt minus x bar square over n minus 1. It means we are summing up all the values of error term. So there are some positive error, there are some negative error. It means when we are trying to sum of these observations, then they are cancelling out each other. And after sum, we have very little information about the error. So the better thing is that to take the square of the error to make it more visible, to make it more elaborative. That is why we are taking the square, because we don't want to lose a single observation from the data. Suppose I am going to estimate a regression. This is a regression. So first error is here, the other one is here, above the mean line and below the mean line. So when we're trying to sum without square, they cancel out each other. The remaining is 0. That is why we are taking the square of these terms. So there is no space of standard deviation in econometrics. We are just make this correction because in square we just take the square of the residual, and in standard deviation we just cancel out the square by taking the square root. Now these are the equations of arch 1-1 process. If you want to make a generalized form of the arch process, then we can write it as RT alpha naught plus X transpose beta plus epsilon T. These are the matrices. This one is the vector of the parameter, and this is the matrix of independent variables. This is the conditional mean equation. Now the conditional variance equation is sigma square T gamma naught plus the condition. Basically we are summing the observations, the lag values like this one, I1 to Q delta I sigma square T minus I. Basically it is a Q time expansion of this term, and I belongs to 1 to so on n time. This is the most basic equation of the arch time modeling. If you have any query about these two equations, please let me know. Otherwise, the next is little bit different from this one, and you will unable to grab that ones. Now, basically there are some problems with this equation. That is why we are going on the next model. The next model after a very near to this one is Garch model, which is the most generalized form of this one. This is also known generalized autoregressive conditional heteroscedastic. Generalized autoregressive conditional heteroscedastic Garch. So the problem is that this model belongs to the symmetric effects. The arch model is unable to estimate any asymmetric effect. Asymmetric effect means any unusual behavior. Suppose there is a break due to COVID, it means that it is an external effect which is unknown to everyone. It suddenly appeared and destroyed everything. So they close the stock markets, or the investor try to, you can say, they pull out their investment from the stock market due to uncertainty in stock market. So it means there is a direct or indirect impact of COVID-19 on stock markets. Nowadays, there is another thing which is Ukraine-Russian war, which is another extreme event for the investors. So the single